All right, hey guys, my name's Nathan Fuller, and I work with a company called FormForge. And so kind of what we do is we use very large industrial robots to manufacture parts in sort of a very unique way. So we are not necessarily a 3D printing company. We are definitely additively focused, and I'll go into more of that in a little bit. But the whole idea behind FormForge is kind of this notion of breaking the mold. So this idea that we spend so much of our time in manufacturing thinking about how we can make tens of thousands of the same part. And the real pitfalls of manufacturing actually are in one-offs, right? It's kind of why 3D printing got that big boon, was this idea that you could make a large number of one-off parts very quickly. And so that's kind of what we said is, what if you made very large one-off parts? But before we talk about that, so I actually worked on a previous startup that was, we were making a hybrid system. So this was a tool that could switch between additive and subtractive technologies. So the idea was that you would print a part and then you would machine it to get really high tolerances and finishes. And you got these really, really cool plastic parts. It solved a lot of problems that we were having with FDM. It also wasn't really quite applicable at this scale. Any of you guys know who've used a 3D printer before, it's kind of just as easy to sand a small 3D printed part down as it is to machine it. And so what happened was that it didn't seem like the small scale desktop market was really the place to bring this technology to fruition. And so we switched to basically it's a very large robot platform. This robot weighs 3,500 pounds. I actually just drove it down I-5. And you get a lot of weird looks when you have a robot behind your truck. But what this is a robot manufacturing platform. It has an extruder that's capable of so a spool of filament typically is 1 kilogram. Our extruder prints 12 of those an hour, right? So we're printing very fast. And it also allows us to print parts that are very strong. So when you go big, you basically get the ability to get higher layer strengths. There's some, for the polymer people in here, there are, your inner layer bonding is almost directly proportional to the length of time your layers spend above what's called glass transition temperature, which is the temperature at which a plastic will shift from a solid to starting to behave like a fluid. And so with larger layers and higher temp layers, you actually get stronger bonds because there's more embedded energy in each bead. And so I'll leave it at that. The parts are stronger, you print them faster, and ultimately, because we're using a 6-axis robot arm, as Taylor mentioned, we get to do some really cool stuff. So with traditional 3D printing, we're all familiar with this, right? Everyone's been here. Like you're halfway through the part, you realize you forgot to turn supports on. Well, with the technology that we first worked on with ExtruderBot, and then that what my company has since begun working on kind of in earnest, is what we call Freeform Additive. So if you notice this part, that part has no support material, but those layers actually eventually are 90 degrees to gravity. Right? And so the idea that we are going to start breaking away from the wasted material that at large scale is a huge problem, right? If anybody has seen the first 3D printed car, there's a huge amount of support material needed to make that, and that's huge waste. And so basically what we're trying to say here is that instead of 3D printing with a ton of waste and very slowly, we're able to print very fast. Yes, question in the back?
How do you cool the material quickly enough for it to be able to support itself?
Yeah, so it was a project that Taylor helped with initially. We've since done a bunch of CFD rounds. There's actually forced air cooling on this, as well as specific polymer selection. So things with glass fiber and carbon fiber conduct heat better and allow you to get a more homogeneous temperature across your part. There's huge issues still when you print this big with thermal contraction, obviously. If anyone's seen a print warp when they print on their printer bot, when you make it 5 feet long, prints warp in inches, not millimeters, right? It's a much larger amount of force you have to counter, and so adding things like fiber helps that. So kind of where we're headed, right? So right now I essentially have like one of the world's largest maker bots, but it uses a robotic arm instead of a gantry. Where we're headed though is So this is actually this is our technology. This is a hybrid. So this is a hybrid print. That gear was printed and it is being machined with a cutting tool. And we do this through what is called automated tool change. So our manufacturing work cell is actually able to take up to 8 different tools. One of them being a print head. We can do subtractive, and we're currently working on some other ideas in terms of things like embedded components. If like you guys have thought about the idea that the 3D printed car isn't a 3D printed car, it's a 3D printed car chassis. You need to install motors, you need to install wires. So actually embedding real parts. And that's an advantage of printing at large scale, is we can do cool stuff, right? We can embed circuitry, we can embed motors. And because we have a robot arm, we can print around them. So they're not an obstacle, we're able to print and sort of encase them in plastic. And so essentially, as a company, our vision is a world where you have one very large box that is able to be customized to customer needs, whether that be just simply additive, hybrid manufacturing like you see over on the left, or even going so far as to create full parts that come kind of out of the machine ready to be installed or ready even to be driven off the product line. So this is sort of the last and most recent thing we've printed. This is a stand for a Chevy V8. And basically the idea is that this part was grown. It wasn't just printed. So it's hard to I wish this part was better angled, but this part actually wasn't printed layer based. Each of the arms supporting this motor was actually printed up like that. And it gives you really cool load properties. If anybody has thought of like a archway, right? Our layers essentially keystone themselves. So the forces are conducted through the part as opposed to trying to break a part or a part of the arm off. I'd love to talk more. There's a lot of cool stuff we're into. And so if people just have questions, I'd love to just kind of open things up to that and see where things go. So.